This LED bar graph here is to demonstrate the B and A inputs. This dip switch controls the B and A inputs. This switch is tied to the function pins S0 to S3. This dip switch here is tied to the carry in pin and the mode pin to switch between logic and arithmetic functions. So to begin, I will demonstrate the f equals not a function, which is a logic function. So my mode select pin will be tied high, carry in pin does not matter. All of my function select pins will go low. And as you can see here, my output bar graph will change based off of the input. So as I add bits, the output will be the inversion of those A bits. As you can see, the B input does not affect the output whatsoever. But as I change the A input bits, the output will change. Next, the inverse of this function is f equals a, which is also the inversion of all the bits in the function select. So instead of all low, I will go all high. Now, my output should reflect my a value. So as I change my a bits, you see my output will reflect that. And again, my B input has no effect. The next logic function I will demonstrate is the f equals a and b function. In order to use that function, I'll go high, low, high, 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 low, high, high. Now, my output will determine a bitwise logic and based off my A and B inputs. So if A and B both have a set input in the same bit, so A0 and B0, A1 and B1, A2 and B2, A3 and B3, if either of those combinations are both set, then there will be an output on that corresponding bit. So you can see as I change my B or A input, my function will reflect the bitwise AND function. The final logic function is the f equals a XOR b function. In order to use that, I'll have to go low, high, high, low. Low, high, high, low. So now, there will only be an output if A and B are different. So if there's one set A bit and a not set B bit. So, as you can see here, A is different from B, but if I flip the same bit on B, the output will turn off. Now, moving on to arithmetic operations, I'll have to change my mode select pin low. So now we're working with arithmetic. I will choose to have no carry, so my carry pin will still remain to be set high. I'll begin by doing the A plus B function, which is high, low, low, high. So I will go high, low, low, high. So now, as I change my B values, let's say A is a 5 and a B is a 1. You can see my output is 6. If I add an extra 4, now my output is 10. If I add an extra 2, my output's now 8. The next arithmetic operation will be A plus A, which is also equal to A shift left 1. So, in order to do that, I'll have to go high, high, low, low, high, high, low, low. So now, as I change my A input, you can see that my B input is reflective of my A input, bit shifted left 1. So my A is a 1, my output's a 2. As I change my A, you can see. And now, if I flip the most significant bit on A shift left 1 is a more significant bit than can be outputted, so the carry out pin will go high. The final arithmetic operation is A plus A and B. I will have to go high, low, low, low. So high, low, low, low. So now, you can see my output will be reflective of A plus A and B. Currently, A is 1 and A and B is 0, so my output will be 1. If I flip the 1 bit on my B, A is 1 and A and B is 1, so my output will be 2. If A was equal to 5 and A and B were equal to 5, my output will be 10. If my A was 7, and A and B was 5, my output should be 12. Thank you very much for watching my explanation of the arithmetic logic unit.